viewers, welcome back to my channel. Today I'm going to be teaching you the structure of alkenes. Alkenes belong to an homologous series in the organic chemistry, and it has a general molecular formula of CnH2n. It is an unsaturated hydrocarbon. So, and it has members. Each of these members are known as homologues, and it is actually an homologous series. They share the same general molecular formulae, but different structural or different molecular formulae. Now, how do you identify alkenes? You see them with double bond. They have double bond. While the alkenes are single bond and they are saturated, while alkenes are unsaturated. Why are they unsaturated? Because some atoms of elements are actually missing in them. Unlike the alkenes that has a single bond surrounded by each of the carbons surrounded by 4 hydrogen or 4 other elements. This is saturated. All the spaces are completely filled. Unlike the alkenes, by the time I'm drawing the structure, you will see that. So let's quickly go into the general molecular formula. Let's use it to get all the members of the group. Now, you're using this series that I use in alkene group. I made a video on that. We are here to watch the video on alkene. Please go back to that and watch this video. And don't forget to subscribe to my channel. All right, let's move on. So the first member here is methane, but there's nothing like that. Do you know why? If we use 1 here, because methane is number 1, 2 multiplied by 1 is 2. That is CH2. There's nothing like that. The least hydrocarbon is CH3, which is an alkyl group. So because of that, methane is not a member of the alkane group. So we have the next member, which is ethane. We have met, et, pro, but, pent, ex, ept, oct, non, dec. We use it to name the alkanes, alkenes, and alkynes. Now, we are starting with 2, which is ethene or ethane. Then the next one is propane. The next, butane, pentane, hexane, heptane, octane, nonene, decene. Now, the ethane has 2 here. 2 multiplied by 2 here is C2H4. While the next member is C3H. 2 multiplied by 3, that is 6. Then C4H. 2 multiplied by 4 is 8. C5H, 10. C6H, 12. Because 2 multiplied by 6 is 12. Then we have 6, 7H. 2 multiplied by 7 is 14. C8. 2 multiplied by 8 is 16. Then nonene is C9H18 and C10H20. These formulae represent their molecular formulae, and it is different from their structural formulae. We can also use it to get their structural formulae. Now, I'm going to be drawing some of the structure of some of this homologous series, some of the members of this homologous series for you. I'll pick butane as an example and ethane. Now, let's start with ethane, which has 2 carbon. C double bond C, because it is unsaturated, it has double bond. Then here, the presence of this, assuming we have 1 bond here, we are supposed to have 3 hydrogen, more hydrogen or any other element attached to this point, as in alkanes. But introduction of this extra bond shows that 1 atom of elements is gone here and 1 atom of elements is gone here. So anywhere you see double bond, 2 atoms of elements, either hydrogen, oxygen, iodine, fluorine, chlorine, they are gone, or even hydrogen halide, they are missing here. Now, so in this case, we can now rewrite ethane as H here, H here, H here, H here, and this double bond represent the functional group of alkenes. Now, let's do that of butane. We have 4 carbon. Normally, butene should be but 1 in, because the functional group will be in carbon 1 from either of the two sides. So let's put the double bond here. It can also be here, so, and you have a single compound. But when you have it in two different places, we call it diene. It has two functional groups. So I'm going to put the double bond here in butene. 1, 2, 3, 4. So normal carbon supposed to be surrounded by 4 bonds. 1, 2, 3, 4. So on the edge here where there is no double bond, you still have your 4 4 bonds complete. The same thing here. 1, 2, 3, 4. So each surrounded by hydrogen. Then here and here, that is where the problem lies. I told you the presence of an extra bond instead of a single bond. An extra bond being added means that 2 atoms of an element has been sacrificed. So in this case, we are supposed to have hydrogen here, 2 hydrogen here, then 3 at the edge here. But we end up having 2 here and 1 here. So the hydrogen can be up or down at the center here, and here we have just 2 left. So this is what butene looks like, and this is both 1 in, because the double bond is on carbon 1. Now the double bond can also be here, and then you get something like this. Now, so I want to correct or make an observation here. Where we have double bond on the second carbon or any other place, like here, assuming the double bond is on the second carbon here. So the first thing is, we don't even know if it's the second carbon. We have to count from both sides. If we count from this side and it's on carbon 2, then it's on carbon 2. If we count from this side and it's on carbon 2, then it's acceptable. But if it's from this side is 2 and from this side it is 3, we are settling for 2. It means numbering, we start from where we have 2. Our carbon 1 will be found there. So in this case now, we end up having but 2 in. You can see that the presence of the extra bond shows that 2 atoms of element will be gone here. So we have but 2 in. This accounts for the reason why butene, alkanes generally undergoes addition reaction, unlike alkanes. Alkanes are fully saturated. All the spaces in the carbon are filled with elements, and so they only undergo substitution reaction, in which we remove an element and replace with another one. But for alkenes, they are not saturated yet, so they can undergo addition reaction either with hydrogen. So changing an unsaturated compound to a saturated compound is actually what we mean by addition reaction, by attacking the double bond with atoms of elements like hydrogen. That's hydrogenation. That is one of the chemical properties of the alkenes. Hydrogenation, by attacking them with halogens like fluorine, chlorine, and they are diatomic naturally. So we have, if I want to write addition reaction plus hydrogen now, this compound will change to the corresponding butane. Where we have single bond, we still have this. Where we have single bond, the double bond will change to, where we have double bond, the double bond will change to single bond, and then one hydrogen will be introduced to make it H2. Then we still have our H fully filled here, and in this case now we have our corresponding butane from but 2 in. So I'm going to use another example, which is pentene. C. Now I'm putting the double bond here. So pentene has C5H10. So we have on this side 3 hydrogen, on this side 3 as well, because there's no double bond. Now where you have this double bond, 2 atoms of elements are being sacrificed. So we have only one left, H. It can be down or up. Then here we have 2 complete hydrogen. So if you count this, you have up to 10 hydrogen and 5 carbon. So how do we name this compound? We call this pentane. But what kind of pentane it is? Is it, if the double bond is on the first carbon here, then it's pent 1 in rather. Now, but because it's on the second carbon, we don't even know, so we have to count from the both side. So 1, 2, double bond is on carbon 2. But if you count from this side, 1, 2, 3, it is carbon 3. So we are settling with that of, we are settling for 2, carbon 2. So it means the double bond, which is the functional group of the alkanes, is on carbon 2. So, and the rule still says that before you can name any compound, watch out for the functional group, then check the longest hydrocarbon, the longest carbon root in the compound. So the longest carbon root here is 5, which is pent, and it is double bond, so it's a pentane. So the double bond is on carbon 2, so we call it pent 2 in, which can also undergo addition reaction once. It can undergo addition reaction with either halogens like chlorine to give you dichloroethane and so on and so forth. So alkenes being unsaturated undergoes addition reaction, and alkanes undergoes substitution reaction because they are saturated. Alkynes is another compound that undergoes addition reaction twice. Alkynes, by the time we are learning the structure, you will understand better. And there's something here which is bromine water. Alkenes can react with bromine water and decolorize it. And this is also one of the ways in which you can test for unsaturation and saturation. Watch out for my video on that. Test for saturation, trying to separate the 3 compounds. There's a way we can separate the 3 compounds. And so from that, we can now use this knowledge to answer this Jamb question. Now let's look at the first one. We have to identify this carbon. The first thing is to look at the longest root hydrocarbon. 1, 2, 3, 4, 5. So if you look at this side, 1, 2, 3, this root is shorter. So this is the longest, 5 carbon. Now what kind of functional group do we have here? We have double bond. So this is an alkene, and then it is pentane. But the pentane is on carbon 2. If I'm not mistaken, let's count from both sides. 1, 2, and on this side, 1, 2, 3. This double bond is on carbon 3 on this side. From this side is on carbon 2. So we are settling with carbon 2. So, but there's a problem. There's an attachment. Instead of having H, C, H, then this is an attachment, a substituent. Then we see have CH, double bond. I told you anywhere you have double bond, 2 atoms of elements will be missing, and that is why 2 atoms of elements are missing here. So we have this H. So because on this side we have carbon 2, we are settling for carbon 2. So this is pent 2 in, but there is a substituent here. So if we name this is carbon 2, carbon 3, carbon 4. If we name number it from this side, we have carbon 1, 2, 3, 4. The functional group will override any other substituent. So this will be carbon 1, carbon 2, carbon 3, carbon 4. If we are to start from here, this will override the functional group. This will be 2 and this will be 4. So, but we are starting with this side because this side is on carbon 2, not carbon 3 from this side. So we are using this as carbon 4. That is 4-methyl. Methyl because it is an alkyl group. Watch out for my video on alkyl group. I think I've made a video on that where we have CnH2n plus 1. We use to form alkyl and other members of the group, all the alkyl groups. So this is 4-methyl pent 2-in. So you can use this method to do this one. This is actually an alkyl, like ethyl, C2H5. The longest hydrocarbon is 1, 2, 3, 4, 5. And there are 2 substituents. This is an ethyl, and this is methyl attached. And this is a double bond, showing that it's an alkene. So if you have to number from our alkene from this side, 1, 2. this is the functional group here. If it's number from this side, 1, 2, 3. So we are going with these 2 from this side. And the second carbon is attached to ethyl, while this is attached to methyl. This is 2, 3, 4. So we have 2 ethyl, 4 methyl, pent 2 in. Please subscribe to my YouTube channel if you are yet to do this, and by clicking this subscribe button below the video, like, share, and also comment on my video. Thank you.